Hello, my name is Him and welcome to our ALU room for our Minecraft final project. So first we're going to read the instruction. Okay, so the instruction is the user to get 3 by adding input A with input B. So input A the user have to make it 1 and input B the user have to make it 2. So when 1 plus 2 it equals to 3 and the door is open. So here as you can see we have two sections, input A and input B. So for input A, we have to make it 1. So we turn the second bit off and the first bit on. So it's get 1. And for the second part, which is the input B, we have to make it 2. So it were the same. Just turn the second bit on and the first bit off. So it's 2. So the door is open. Okay, so let's go out and check our logic behind it. So we apply to be adder for ALU. So let me change the time first for showcasing is better. Okay, so for to be adder, each number it has 2 bits. So we have to add it by each column. First some column is to add A1 and B1. And here I have an AND gate. So it's come from the B1 and A1. So in binary adding, 1 plus 1 doesn't just give us 2. Instead, it gives us 1 0 as binary that equal to 2 in decimal. So for 0 is for the sum that we write down, and for 1 is like for the column that we write, that we call it as carry. And our second gate is OR gate, so you can see it the same as AND gate. So it came out from A1 and B1. And why do we need OR gate? The main reason is to build XOR gate. So for OR gate, it check if either one of the switch is on. If either one of it or both of the switch is on, the dash will light up, like it runs as a loop. But if both of switch is off, or the dash will turn dark. And next we talk about the inverter. So about inverter, it take the AND gate answer and flip it to the opposite, which means if the AND gate is lit, the inverter will turn dark. But if the AND gate is dark, inverter will be lit. The reason we need it is the same as OR gate. We use inverter to build the XOR gate. Now go to our XOR gate. So about XOR gate, it's a real sum calculator. It combines from OR out gate with NOT and OUT gate, or we call it as an inverter. XOR gate it lights up only when the two inputs are different, which means one's on and one's off. In example, like if A1 and B1 are different, the answer is 1, but if they're the same, the answer is 0. And opposite of it is our bit 1 sum. And next we go to A2 plus B2. So for A2 plus B2 it works kind of similar to A1 plus B1, you just need add more sum logic. So we have AND gate the same. For AND gate it's just to check if both A2 and B2 are on the same time. About the output is called the partial carry. It's not a final carry yet, since we still need to combine it with bit 1 carry later. And next let's go to our OR gate. So about OR gate it's a check if at least one of A2 or B2 is on. And the reason we use OR gate is to build XOR gate. And this is the inverter, we use it to flip the AND out. Next, let's go to our XOR gate, the combine from OR out plus NOT and OUT gate. So what it does, about XOR gate, it turns on only when A2 and B2 are different. And about the output is called partial sum. And this is not the final bit to answer yet because it hasn't accounted for anything carry over from bit 1. And next let's go to round 2 for bit 2. It's a combine the partial sum with bit 1 carry. So here is the carry from bit 1. You can see we connect it to partial sum to make an AND gate. And the reason of it is to check if both partial sum or bit 1 carry is on. And its output is called second partial carry. So mostly for it used for like 4-bit version or something, but for us we only do it for 2 bits, so I think it's not necessary for it. And about next we have an OR gate. So OR gate is combine the part of SAM. Here goes to the bit 1's carry. So the reason we need it is just to check if at least one of these two is on. And you can see the light that run as low is all lit for all gate. And as before, the next part we have inverter from the AND gate. It just flip the AND gate answer. So the next part we also have an XOR gate. It's the combine from all out with NOTs and out. For XOR gate, it just turn on only when the path of SAM and bit 1 carries are different. And that is our real final bit 2 SAM. So we got all the bit 2 SAM, final bit 2 SAM and bit 1 SAM. So the last part is just connect both together by use AND gate. Here you can see we connect the bit 1 SAM with the bit 2 SAM, which means that is required both correct, so the door will open. And this is the dash line that we connect to the door. So let's just go back here. Our door when both section A and B are correct. So let's just turn it on to test. And in here, input A we get 1. It's not open here. And input B we got 2. So it's all 3 and the doors open. And that's all for ALU. Thank you.